Okay, we're going to go through questions 8 through 14. So first question, number 8, what is the pattern of this data? So remember when they ask you for the pattern of this data, there are a few options. You have a bell curve. Bell curves look something like this, kind of like a hill or a mountain. It only does that one time. You can't have multiple like hills. It's just the one big bell. Then there is skew. You have a left skew and a right skew. And remember that these skews are when you have a lot of data on one end and not very much on the other, right? So it's all kind of clumped up on one side and it kind of trails off the other side. It's named left or right based on the side that has the least amount of data. So that seems a little backwards, but like a left skew is going to barely have anything on the left, so it's going to look like that. Or a right skew is going to have barely anything on the right, so it's going to look like that, where all the data is here on one end and it kind of trails off on the other side. And then finally there is uniform distribution. And think about what that word uniform means. Like if you wear a uniform, right, everything is very the same. Everyone looks the same, they're wearing the same thing. So same here, uniform distribution, it's all basically about the same number. So it kind of just ends up looking like that, almost like a flat line that just kind of barely goes up and down. It doesn't vary very much. There's not a lot of variety to the data. It just is all kind of the same. So with this graph, anytime I get a graph and they're asking me the pattern, I like to kind of just draw along kind of what the shape is. So I can see here that there's a lot of data happening over here on the right, and it just kind of trails off over here on the left. So this is definitely a skew. And then again, I would think about, is this left or right skew? So all the data is here, and then it trails off on the other side. So the side where the least amount of data, the left is what it's named after. So this is a left skew. Okay. Then let's look at number 9. So a park ranger measured the heights in inches of 11 newly planted trees. The results are shown below. Which box and whisker plot represents the heights of the trees? Okay, this is a little bit tricky because we are going to need to find the pieces that make up a box plot to be able to help us identify which of these would make the most sense. So on the bright side, they did already put the data in order for us. So that is actually very helpful. So what I'm going to do is I'm actually going to rewrite it just so I can see it a little bit better. We have, am I going to be able to do that? Let's see how good I can do this. So we have 20, 21, 24, 30, 31, 38, 35, 38, oh my goodness, 40, 42, 43, and 44. Okay, let me scoot that. Oops, let me scoot it. It doesn't want to scoot for me. Let's try one more time. There we go. I'm going to scoot it down here where I've got a little bit more space. Okay, and we need to find all the pieces, right? So the pieces of a box plot are the lower extreme, the lower quartile, the median, the upper quartile, and the upper extreme. Okay, so as we go through this, I will identify all those pieces. So the upper and lower extreme, those are just these biggest and smallest numbers. So that part's pretty easy. Lower would be less, so 20 is our lower extreme. Upper would be the bigger one, so 44. And just knowing those two, I'm going to go up here and see if that kind of gets rid of any of these answer choices. So my lowest point on the graph should be 20. So A looks fine, B looks fine, C is a little off, and D is definitely off because it's at 10. So I can go ahead and get rid of D. C, I'm thinking I can probably get rid of as well. It looks like it's at more like 21. So I'm going to go ahead and cross C off too. So look, we've already narrowed it down to A or B. And before I even keep going, let's see, the 44 looks good on both of those. I can see already on here that on the A and B graph that they both have a median at 35, so that's not going to tell me very much since they both think that 35 is the median. I'm going to assume it's probably really the median. But I can see the lower quartile here and here. Those are at different spots. So that's the number that's probably going to be able to be the most helpful for me. So now let's go ahead and find those things. So I have to find the median before I can find the quartiles. So finding the median, remember you would cross them off, working your way in to the middle, and there's 35 at that median, just like we said we thought it would be right there. So that stays just how it is, A and B. And then remember that on the sides of the quartile, you're going to, or sorry, on the sides of the median, you're basically going to find the median on each side. So cross that off, cross that off, cross that. 24 looks like my lower quartile. Again, 35 is my median, and on the other side, cross, I get 42 as my upper quartile. So now looking back at my picture, 24 is my lower quartile. For A, that's hitting more like 26 or 7. On B, it's hitting at 24. So actually, B is going to be our answer for this one. Okay, this is a very similar problem where they are asking us to look at the data set and see which of these graphs would be matching to that. So I can already see, look, the data's in order. It goes from 12 up to 67. And let's see, if 12 is my smallest number, that doesn't cross anything out, so that's helpful. Remember with histograms, the ranges do have to be the same. So if I'm looking, it's 11 to 20, 21 to 30, 31 to 40, 41 to 50. Okay, A looks fine, I think. B looks, let's see, a little iffy because I can see down here at B it goes from 1 to 20 and then 21 to 40, that's fine. But then 41 to 50, the first two were ranges of like 20 numbers, and this is only a range of 10 numbers. So B just isn't even really a histogram. I have to get rid of that just because those things at the bottom don't make sense. C, the ranges are fine. D, I think the ranges are fine. Okay, so now what I would do is I'm going to break it up into these groups. Okay, so if I'm looking at numbers, let's see, for A, it's 11 through 20. I'm going to break it up 11 to 20. So it looks like it's these 4 numbers are between 11 and 20, and that's what they said it was going to be for A. And then let's see, 21 through 30 is this 1, 2, 3, 4, that's 5 numbers, and they said it was going to be 5. 31 to 40, there aren't any, just like they said. 41 to 50, let's see, is right here. 1, 2, 3, 4, 5, 6, and that's what they said it was going to be. 51 to 60 is these 2, they said 2, and 61 to 70 is 3, they said 3. So that looks perfect. I'm going to go ahead and look at the next one. 11 to 20 was 4, just like we said. 21 to 30 was 5, like we said. 41 to 50 was, they said 6, that's correct. 51 to 60 was 2, and 61 to 70 was 3. So the biggest question is, oh, look, they skipped a whole section here in C. You see how in between this section right here, it goes straight from 30 to 41. So that is not a good example of a histogram either. And then finally down here at the bottom, you can just see the numbers don't match up. It was 4 in the first category, they only have 2, so it's not D either. It has to be A. Oh, those two are tricky. Okay, so now what is the number of observations for this graph? Remember, observations is just how many pieces of data did they gather. First thing I do when I get a histogram is write down how many each bar is worth. So this is 4, 2, 4, 1, 1, and then that makes it easier to add up. 4 plus 2 plus 4 plus 1 is 12. Okay, just add those together. 4 plus 2 plus 4 plus 1 plus 1. That's how we get to 12 observations. Okay, number 12. What is the attribute of this graph? Remember, attribute just means what's this graph about? And it pretty much always comes from the title. So height by toddler at Miss Cabrera's daycare. That is our attribute, what the graph is about, the title. Number 13, what's the means? Okay, I don't mean the mean, like the average. I mean the means with an S. That's asking me like the tool that the unit was measured in. So this was measured in centimeters. What tool did they use to do that? A ruler. Okay, what actual tool? You're not going to see it on the graph. You're just going to need to know what it is. Okay. And finally, question 14, the dot plot shows the number of days each student was absent from Miss Jordan's class during 1 month. Which statement is not true? Which one is not true? Okay, so the data clusters from 3 to 6 days. 3 to 6. So a cluster is where a whole lot of data is broken off from another piece of data. So that doesn't seem right. I don't think that this is a cluster. So I'm thinking that's my answer, but let's go ahead and check the other things. So the mode is 0 days. Remember, mode is the one that occurred the most often. Yes, this is the tallest one. It's at 0. That is the mode. There are 20 students in Miss Jordan's class. Yes, if you count all the dots, there are 20 of them. And there's no gap in the data. Remember, gap is when there's a piece of data missing. So if there was a graph and you had points, but there was a spot like right here where no data was, and it has to be in between. I always think like a gap in my teeth. It's in between the teeth, right? So it's got to be in between some data where it's missing. That would be a gap. So there is no gap in this data. And A was the right answer.